So good day. So today we will answer a problem from the course unit 6, mechanism of heat transfer, specifically the exercise number 1 in the page 8 of this course unit. So here we are, the problem. So I will read this and answer it. So suppose you are designing a cooler made from fiberglass plates 5 cm thick that could maintain its cold state at 0 degrees Celsius by ice in a surrounding temperature of 27 degrees Celsius. If 2 kg of ice melts in one day, what is the total wall area of the cooler? The thermal conductivity of fiberglass is 0.04 watts per meter degree Celsius. So first, let's list down all the given factors to be considered in solving this problem. So given here from the problem is the thickness of the fiberglass plates. So denoted by the letter L. So L is equal to 5 cm. So to be consistent or uniform, let's convert this 5 cm to 0.05 meter by multiplying it to 1 meter over the equivalent in centimeter is 100 centimeter. So 5 centimeter times 1 meter over 100 centimeter is equal to 0.05 meter. Next, we are given the temperature at the cold side. So its cold state, so it is equal to 0 degree Celsius. Next given is the surrounding temperature or the temperature on the hot side, which is equal to T sub H is equal to 27 degrees Celsius. Next, the given is the mass of the ice that melts in one day, which is equal to 2 kilograms. Next, we have the time. The time here is 1 day. So we can transfer this, or it is equivalent to 24 hours in a day. So 24 hours, and these hours, let's convert this to a smaller unit to be uniform and consistent, which is seconds. So 24 hours times 60 minutes over 1 hour times 60 seconds over 1 minute. So hours will cancel, minutes will cancel, leaving us the unit of seconds in our final answer in the time variable. 24 times 60 times 60 is equal to 86,400 seconds. Last, we are given the thermal conductivity of fiberglass, which is denoted by K, and K is equal to 0.04 watt per meter degree Celsius. So find. So what is asked in this question? So it asks, what is the total wall area of the cooler? And denoted by letter A. So our solution, so let's first get the Fourier law of conduction formula. So Fourier law of conduction states that the heat current of conduction of an object is directly proportional to the cross-sectional area times the temperature difference and inversely proportional to its thickness or length. So here I list down the heat current formula. Then from here we can extract the value or the variable A in the area. We can do some algebra to extract the A. So here I perform the extraction. Here we perform, and we come up with this formula. So A is equal to the length or the thickness times the heat current all over the thermal conductivity K times the temperature difference. In short, the temperature on the hot side minus the temperature on the cold side. But the problem is we don't have the value for our H. So to get the value of H, so we can use the basic heat current formula, which is H is equal to Q over the time. So Q here is the heat transferred or from the first law of thermodynamics, or the law of conservation of energy. The Q is the amount of heat rejected or added. To get the Q, we can use another formula. So Q is equal to mass times the L, or the latent heat of fusion of ice. So from the table, or from what I've researched, the latent heat of fusion of ice is equal to 334,000 joule per kilogram. So let's substitute it. Q is equal to mass, which is 2 kilograms, times 334,000, which is the latent heat of fusion of ice. And kilograms will cancel, and that will leave us 668,000 joules. And let's go back to our basic formula for heat current. So let's direct substitute it again. So here 668,000 divided by our time in seconds, which is equal to 86,400 seconds, and that will give us the answer for the heat current, which is equal to 7.95 joules per second, or 7.95 watts. And going back to the formula for area to get our final answer, so let's substitute this H. So let's go back. So A is equal to the thickness, or it is equal to 0.05 meter. Directly substitute it, times the heat current, or the 7.95 watts, all over our thermal conductivity K, which is equal to 0.04, times the temperature difference, temperature of the hot side, which is equal to 27 degrees Celsius, minus our temperature at the cold side, which is equal to 0 degrees Celsius. Performing this, we get the value in the numerator, which is equal to 0.3975, and another for our denominator, which is equal to 1.08. Dividing this, 0.3975 divided by 1.08, we get our final answer, which is equal to 0.36 square meter. So this is the total wall area for our designed cooler made from the fiberglass plates. So that ends our answering in solving this exercise number 1 for the mechanism of heat transfer in the course unit 6. Thank you for listening.